Hello, my name is Marc Potocnik. I'm a designer and founder of animation studio renderbaron. renderbaron is focused on high-end visualization and visual effects for TV, for commercials and for events. I'm running the studio now since 2001 and my tool for daily 3D creation is Maxon Cinema 4D. While there's no doubt that as a 3D artist you're in the rendering business, it would be a bit simplifying to equate the 3D creation process with just 3D rendering. So it would be a bit like looking at the Sistine Chapel, the ceiling of Sistine Chapel, and just looking at the section where Michelangelo let the finger of God touch the finger of Adam. So you would neglect all the scenarios around it. So it might make sense to take a step back and see the bigger picture, the complete 3D creation workflow. In this video, I'd like to give you an insight into the workflow of one of my favorite animation projects so far called Apollinarisstr. For doing so, I will show you how the individual steps of a workflow are weighted in a project like this. I will also take a look at where Intel technologies can support a 3D artist in an everyday workflow. Enjoy!
Was willst du denn da?
Nix. Licht. Apollinarisstr was created for Intel and Maxon to test the power of Intel's latest CPU workstations. The project should contain everything that challenges render engines the most: a highly realistic light setting, caustics, subsurface scattering, area shadows, ambient occlusions, soft reflections, etc. Additionally, the scene should contain a high number of objects and polygons. For this project, Intel provided me with a dedicated workstation equipped with an Intel Xeon W3175X CPU with 28 cores at 3.1 GHz. Its performance accelerated the creation process noticeably and boosted the whole project. Later on, the project was re-edited on an even faster machine, a dual Xeon Platinum 8280M machine with 2 times 28 cores at 2.7 GHz. This machine was also provided by Intel and the performance was just overwhelming. During rendering, the clock speed leveled at about 2.9 GHz and reached a Cinebench R20 value of about 19,000 points. This powerhouse blazingly fulfilled all the project's requirements. As a side note, this dual Platinum machine is extremely powerful, but it would also be very expensive to buy. Intel's Xeon Gold CPU line, on the other hand, offers absolutely comparable rendering performance, but at about 1/3 of the price per CPU, so I think this is worth to mention. The actual production is always preceded by a phase of pre-production. This phase includes considerations of content, of setting, look and feel. Visually, my goal was to create a kind of animated still life. A simple everyday kitchen in the morning in spring, used, worn out and flooded with light. The animation should appear very lifelike. The overall result should follow, let's say, a found footage style. In order to implement these conceptual considerations, it was necessary, of course, to take reference pictures showing tomatoes, apples, oranges and other stuff in direct sunlight. With the help of these references, I was able to study shapes, surfaces and light behavior and get insights how to rebuild these in Cinema 4D. Can the shape of an orange be modeled purely procedurally? Can I create surface structures of an orange purely procedurally with a standard material system of Cinema 4D? With the first modeling and shading proof of concept, I positively tested this and headed over to the actual scene creation. The first big part of the actual production was the modeling of all scene elements. All elements were modeled from scratch, existing assets from libraries were not used. The modeling was mostly procedural and techniques used were spline-based generator objects, parametric primitives in combination with deformers, subdivision surfaces, or volume modeling with Cinema 4D's open VDBs. For a realistic and rich image, it is important to create a high level of detail in modeling. However, this level of detail must be used specifically to guide the viewer's eye and to do a director's job. Thus, in some areas of the picture a higher level of detail should be present, but maybe not in others. For doing so, scattering of tiny objects such as hairs on tomato branches or dust fibers can help to guide the eye. Let's take a live look at the tomatoes to see what such a concentration of detail looks like in practice. Here we have the branches. The branches are based on sweep objects that run a radial profile spline along another axial spline. The resulting hull can then be changed in its diameter by a curve. If several tube-like objects like this are combined in a volume object, an organic hull overall is obtained. The volume object itself allows you to combine objects by Boole operation, and in this way, for example, objects can be used to create holes and cuts in the branch. A polygon version of this volume object is then used as a base to place hair-like objects on it. These objects are just sweep objects converted to polygon objects. I used a MoGraph cloner to scatter them across the polygon surface of the branch and a random effector to vary size, position and rotation. In order to use a high number of clones, it is necessary to use a cloner mode multi-instances to prevent performance degradation in viewport and rendering. The basis for creating complex structures in the standard material system of Cinema 4D is the so-called layer shader. This allows the stacking and mixing of shaders and image textures as layers, similar to Adobe Photoshop with different opacities and blend modes. In the case of the apple texture, only procedural shaders are used, mainly noise and gradient shaders. So let's have a look at this in detail. Here, in the layer shader, there's a color shader as a basis, which only creates a plain and simple color, nothing else. Above it, there's a folder created with a button up here. In this folder, you can create different shaders that are combined by the folder function and thus act like one single layer. In this case, there are 3 noise shaders on top of each other. The folder itself is in layer mode layer mask and thus masks the reddish color shade above it with its brightness information. And that's the first color structure for our apple, created by just 3 combined noises, masking the red color to the yellow color below. That's all, and that's the whole principle, which gets repeated several times further up for small turbulence noises, stripes of long noises, small spots or long light stripes. Turbulent 2D color gradients on top additionally provide natural looking structures. In the luminance channel, subsurface scattering, colored by a similarly constructed layer shader, provides a subtle but very important translucency. The bump channel provides matching noise structures, and a wide GGX reflection model is active in the reflectivity channel. During the process of shading, it is also helpful to have some real references at hand, so make sure to have some tomatoes and oranges lying around while doing the job. In general, for the creation of natural details with Cinema 4D's shader system, it is of course important to have a profound knowledge of the shaders available in Cinema 4D, especially the noise shaders. But then, it's amazing how much detail you can get into with procedural shading, completely rule-based and without touching one single pixel. Regardless of how random or found footage-like your final animation is supposed to look, it is always a good idea to provide your scene with a color concept that makes the composition more coherent. Color schemes and contrasts are important tools in this process. For example, here the highly saturated colors of tomatoes and oranges clearly attract your attention as a viewer. Then this red and this orange are contrasted in a complementary way by the bluish colors of the objects behind. At the same time, red and orange are continued by other same colored elements in the scene. Through such contrasts and the continuation of colors, different areas of your composition kind of communicate with each other. This intensifies the atmosphere of the scene and strengthens your whole composition. The process of lighting is essential for the visual impact of your scene. With light, a scene can be greatly enhanced or completely spoiled. Depending on light, completely different moods can be created and thus stories can be told. It is therefore elementary to understand lighting as a deeply creative and only then technical process. In Apollinarisstr, a low-angle yellowish light source suggests a morning sun, and since bright white shades dominate the kitchen, indirect light seems to flood the scene. How was this done? In my animation work, I prefer to use only direct illumination and not to use global illumination. Why? It enhances your own lighting skills and allows you to directly control every imaginable aspect of light. In addition, it can offer some serious advantages in speed and predictability when rendering animations. Let's have a look at the light sources involved here. The basis for daylight is an area light that has been given a slight color gradient by texture tag to simulate ambient coloration. Then, a parallel infinite light with area shadows serves as a sunlight. A small sky dome, also an area light, is used for the diffuse illumination of the objects on the kitchen counter. Last but not least, a handful of manually placed lights then create the illusion of indirect light bouncing off surfaces. The resulting light setup is then complemented with subsurface scattering on fruits and vegetables, and by my proprietary shader setup, shadow luminance, which brightens up less illuminated areas of objects. As the fruit and vegetable plates in the scene are kind of, let's say, extra still lifes, they get a few extra bounce lights. So in the end, the scene contains around 15 light sources in total, and my guess is you wouldn't know that this is done with direct illumination only. For rendering, I use my own in-house render farm. It consists of Intel Xeon and Intel i9 workstations, which are involved in distributed rendering via Cinema 4D Team Render. Cinema 4D's internal CPU render engines, physical render and standard render both benefit from an Intel technology called Intel Embree. These are ray tracing instructions that are optimized for Intel CPUs and accelerating the rendering of large amounts of geometry in Cinema 4D. Here's an example: the kitchen scene, only with geometry and light. Without Embree and with Embree switched on. So far, no difference. But with Embree switched on, the render time is reduced by almost 50%, and that's remarkable. The final animation was rendered using Cinema 4D's internal physical renderer. This engine is based on stochastic sampling and therefore benefits from the Intel Open Image Denoiser. This AI deep learning based denoiser improves the image quality of noisy images and therefore saves rendering time, especially with numerous render iterations. And the denoiser comes into place when it really matters, for ray tracing based features such as area shadows, ambient occlusion, depth of field, etc. By the way, this project was created with physical render, but in the meantime, I switched my studio to the great external render engine Corona Renderer. And the cool thing is, Corona also uses Intel Embree and optionally the Intel AI Denoiser. When I create scenes in Cinema 4D, I always strive to make my work look good already while rendering. So compositing in Adobe After Effects CC is mainly for gradation correction and color correction. Another important purpose of compositing is to transform the mathematically perfect rendering into a credible analog-looking image, as if it had been filmed with a slightly imperfect optical system. For this purpose, I use Magic Bullet looks from Red Giant for an example for applying chromatic aberrations. Effects like glow, 2D motion blur, vignette and film grain round off the illusion of a filmed scene while doing compositing in After Effects. The usual way for encoding is to output an uncompressed AV file from Adobe After Effects, which I can then flexibly write to various formats and codecs using Adobe Media Encoder, for an example for video platforms like YouTube and Vimeo, or for offline presentations at the customer site. So thank you for watching. And a big thank you to Intel and Maxon supporting this project. I hope you enjoyed this video and happy creating!